Chapter 12, Section 3, we're looking for the trigonometric functions of general angles. And general angles is including angles that are larger than 90 degrees. So what we want to do is we want to start with our angle again with our initial side and standard position on the positive x-axis. We locate some point P, which has an xy component on the terminal side, whichever quadrant it may be in, and let r represent the distance from the origin to the point P. So in example 1, we're going to find all the values of all 6 trig ratios of an angle theta in standard position whose terminal side passes through the point 8, -15. So here's the situation that we have. We've got the initial side starting on the positive x-axis. We're rotating our angle counterclockwise. Here's our terminal side, and this point is the point 8, -15. What that means, since the x value is 8, that this horizontal component of our triangle is 8 units. And the y component, remember that the length always has to be positive. So even though the -15 indicates that the direction of this is in quadrant 4, the length of this side of the triangle must be positive 15. And the hypotenuse, the distance from the origin to point P, we're going to represent as r. Doing the Pythagorean theorem, r squared is 8 squared plus -15 squared. So 8 squared is 64, -15 squared is 225. 64 plus 225 is 289. The square rooting both sides, the square root of 289 is 17. So we've got the 3 sides of our triangle now, 8, 15, and 17. With that in mind, we can go through and find the trig ratios. So let's begin with the sine ratio. Remember that sine was the y value over r. So in this point, the y value is -15 over r, which is 17. Now, we're using the y value of the point rather than the distance of this side here, and we'll make that clear a little bit later. For right now, let me just tell you in quadrant 4, sine of any angle in quadrant 4 should give us a negative answer. Cosine is the x value over the radius. So the x value is 8. The radius is 17, representing the hypotenuse. Tangent, as we recall, was the y value over the x value. The y value being -15 of that point. -15 over the x value, 8. So that's -15 over 8. Then we've got the reciprocals. The reciprocal of sine is cosecant, so that's r over y. In this case, that's 17 over -15. We don't like to leave a negative number in the denominator of a fraction, so if we multiply numerator and denominator by -1, that moves it to the numerator. Secant is the reciprocal of cosine, so that's r over x. R is 17, the x value is 8. Cotangent is the reciprocal of tangent, so that's x over y. The x value is 8, y value is -15. Again, we'll multiply numerator and denominator by -1 to move the negative sign up to the numerator. Alright, well, let's take a look at the summary. We said here that the sine of any angle in quadrant 4 should be negative. As we look at that in quadrant 4, tangent gave us a negative answer, cosecant gave us a negative answer, cotangent gave us a negative answer. So 4 of them in quadrant 4 are going to give us negative answers. Remember, we've got quadrant 1, quadrant 2, quadrant 3, quadrant 4. And in quadrant 1, in general, any angle between 0 and 90 degrees, if you take sine, cosine, tangent, cosecant, secant, cotangent, all 6 trig ratios should be positive answers. In quadrant 2, between 90 and 180 degrees, only sine should be positive, and its reciprocal cosecant. The other 4 trig ratios should be negative. In quadrant 3, between 180 and 270, only tangents and tangent's reciprocal, cotangent, should be positive. The other 4 trig ratios should be negative. And in quadrant 4, as we just illustrated in the previous example, only cosine and secant, and of course remember cosine and secant are reciprocals, are positive in quadrant 4. All the rest should be negative. Now, I try to find some sayings to help you remember this, and let's remember I'm 75% Norwegian, 25% Danish. I'm Scandinavian, so I'm bashing my own culture. But if you take the A from all, S from sine, T from tangent, actually the whole word, and C from cosine, you can think, well, all Scandinavians tan carefully. We're fair-skinned and we don't want to get sunburned, so all Scandinavians tan carefully. Maybe you've got another way of remembering that. But don't forget, it's not only sine, but it's reciprocal as well. Tangent and its reciprocal, cosine and its reciprocal as well that are positive. The others are negative in those quadrants. All right, we've done one similar to this if we've looked at the unit circle exercise. This is a quadrantal angle, 180 degrees. So we're starting out with our positive initial side on the positive x-axis. Rotate counterclockwise 180 degrees. Our terminal side's on the negative x-axis. I didn't draw the circle here because I was drawing it kind of small. But imagine a circle going through these 4 points. Again, the unit circle, that gives us 1, 0, 0, 1, negative 1, 0, 0, negative 1. So the distance here between the origin and any point is 1. It's a radius of 1. So for 180 degrees, what we want to look at is a radius of 1 and the ordered pair negative 1, 0. Sine is the y value over r. In this case, the y value is 0 over anything is going to give us 0. So sine of 180 degrees is 0. Cosine is x over r. So the x value is negative 1. R is still 1. So the cosine is negative 1 of 180 degrees. Tangent is y over x. The y value is 0. The x value is negative 1. 0 divided by anything is 0. So the tangent of 180 degrees is 0. Cosecant is the reciprocal again of sine, so that's r over y. The radius 1 over the y value 0. We can't have 0 in the denominator, so that's undefined for the cosecant of 180 degrees. Secant is r over x, the radius being 1, x being negative 1. 1 divided by negative 1 is negative 1. Cotangent is 180 degrees. That's cotangent ratio is x over y. The x value is negative 1. The y value is 0. We can't have 0 in the denominator of any fraction. So the cotangent of 180 degrees is undefined also. Now, I went through that a little bit more quickly, but we covered these quadrantal angles in the unit circle in a separate little lesson, so that's why I went a little bit more quickly in that regard. If it's not a quadrantal angle and it's larger than 90, what we want to do is find an acute angle, which is one less than 90, associated with that angle, and we call it the reference angle. A reference angle is an acute angle formed by the terminal side of our angle and always the x-axis. Always the x-axis, never the y-axis. So in this scenario, if we're looking for the reference angle for 140 degrees, we start with our initial side on the positive x-axis. We rotate counterclockwise 140 degrees to our terminal side. To find the reference angle, it's always the angle formed by the terminal side and one of the sides of the x-axis. In this case, it's the negative x-axis. And so if we drop a perpendicular from our terminal side to the negative x-axis, this angle right in here inside the triangle is 40 degrees. The way we get that is the straight angle all the way across is 180 minus this 140 leaves us 40 degrees here, which is the reference angle for 180. Right now we're just finding the reference angle. We're going to put them to work for us a little bit later. But again, the reference angle is the acute angle formed by the terminal side and the positive x-axis always. Let's find the reference angle for 300 degrees 10 minutes. So we're going to draw an angle of 300 degrees 10 minutes to the best of our ability. Start with the initial side on the positive x-axis. Rotate counterclockwise 300 degrees 10 minutes. There's our terminal side. Make a perpendicular with the x-axis, always the x-axis, never the y-axis. And then we're going to look for our reference angle, which is the angle formed by the terminal side and the x-axis. Now all the way around would be 360 degrees. So 300 degrees 10 minutes, we've stopped short of 360, which is all the way around to this positive x-axis. So 360 degrees minus 300 degrees 10 minutes is 59 degrees and 50 minutes. Remember, we can't subtract 10 minutes from, there's no minutes here. So let's borrow a degree from 360, make that 359. And that degree we're going to turn into 60 minutes. So 60 minutes minus 10 minutes is 50 minutes. The 359 degrees minus the 300 degrees is 59 degrees. And this works for negative angles as well. So let's draw a reference angle for that. Our initial side is on the positive x-axis. And negative 135 means we rotate clockwise to get to our terminal side of 135. And the reference angle is always formed by the terminal side and the x-axis. Always the x-axis, never the y-axis. All the way around here would be a coterminal angle of 225. Sometimes we like to work with numbers a little bit in the positive realm. So the coterminal angle of 135 is 225. And we'll use that positive angle to help us find the reference angle. The 225 is past 180. Starting at the positive x-axis, if we rotated 180 to get a straight angle, we went past it to get the 225. So 225 minus 180 is 45 degrees. And 45 degrees is the reference angle for a negative 135 degree angle. And for its coterminal angle, 225 degrees as well. Alright, let's continue. Now let's put these reference angles to work and find the cosine of 210 degrees. So let's start out with the reference angle of 210. I'm not going to draw the picture, but 210, as we rotate counterclockwise, passes by 180. That's the nearest x number as a reference. So 210 minus 180 is 30 degrees. But we're in quadrant 3 here. And if we remember, all Scandinavians tan carefully. In quadrant 3, only tangent and its reciprocal cotangent are positive. So cosine, therefore, must be negative. So cosine of 210 degrees is the same as the opposite of the cosine of 30 degrees. And as we recall from our previous lesson, from our 30, 60, 90 triangle, cosine of 30 degrees you were supposed to memorize. That's the square root of 3 over 2. But in quadrant 3, it's negative the square root of 3 over 2. All right, let's look for the tangent of 330 degrees. 330, the closest x-axis angle, was stopping short of 360. So 360 minus 330 gives us a reference angle of 30. We need to figure out what quadrant 330 is in. And yes, that's quadrant 4. In quadrant 4, tangent is negative. Remember, all Scandinavians tan carefully. Tangent's only positive in quadrant 1 and 3. So in quadrant 4, it must be negative. So the tangent of 330 degrees is the same as the opposite of the tangent of 30. We asked you to memorize the tangent of 30 before, or quickly review it in your head from your 30, 60, 90 triangles from geometry. So the tangent of 30 is the square root of 3 over 3. And in quadrant 4, that's negative the square root of 3 over 3. If you're headed for pre-calculus, these are things that, again, you should be very familiar with and be able to do quickly. Let's do this one without drawing the picture. A negative 225 is, first of all, let's find its positive coterminal angle equivalent by adding 360 to it, and that's a 135 degree angle. If you visualize in your head, that's going to end in quadrant 2. So we're stopping short of 180 degrees because reference angle is always the terminal side in the x-axis. X-axis is either 0 degrees, 180 degrees, or 360, and you're either adding or subtracting to it or from it. So 180 minus 135 is 45. Cosecant is actually positive in quadrant 2. Cosecant is the reciprocal of sine, all Scandinavians, so that's positive in quadrant 2. So we can say that the cosecant of 225 is the same as the cosecant of 45. And the cosecant of 45 degrees, if you visualize your 45, 45, 90 triangle in your head, that's the square root of 2 over 1, or just the square root of 2. All right, now we're going to get a little bit more tricky. We want to find sine and tangents of theta. And our hint is the cosine of theta is negative 2/5. And my angle theta is somewhere greater than 180 and somewhere less than 360. Now, we got to play a little detective here. Greater than 180, less than 360 means we're in quadrant 3 or we're in quadrant 4. So we're in quadrant 3 or quadrant 4. Where is cosine going to be negative? Well, cosine is positive in quadrant 4, but since here cosine is a negative answer, cosine is negative in quadrant 3. So now I can draw my picture. My initial side on the positive x-axis. We rotate counterclockwise, get to our terminal side in quadrant 3. Now, by this length is not negative 2, but this point is the point negative 2, 5. And I don't know this side yet, but we'll come to it when we get there. Let's start out with the cosine again. Remember, cosine is the x value over the radius. The x component has to be negative 2. The radius or the hypotenuse has to be positive 5. So let's do the Pythagorean theorem again. The hypotenuse is 5, so the hypotenuse squared, or 5 squared, is y squared plus the 2 squared. And so 25 is y squared plus 4. Subtract 4 from both sides. Y squared is 21. Square root both sides. And y is the square root of 21. Now that we know the three sides, and again, this is just a reference. The length is not negative 2. But this point over here is negative 2, 0. Now that we know the three sides of the triangle, we can go ahead and find sine and tangent. Sine is going to be, from this point of view, opposite over hypotenuse, square root of 21 over 5, but I've got to be careful because in quadrant 3, sine is negative, so I'm going to add a negative symbol in front of it to keep that true, because all Scandinavians, the Scandinavian stands for sine, sine is positive in quadrant 1 and 2 only, so I have to make it negative in quadrant 3. Tangent, well, from this point of view, opposite over adjacent, it needs to be positive in quadrant 3. All Scandinavians tan carefully. So whatever I get for the tangent in quadrant 3 better become a positive reference. So that's the square root of 21 over 2 in simplest radical form. And that's our first look at finding 6 trig ratios of angles that are larger than 90 degrees and using their reference angles.